Imagine going outside tomorrow and being told your birthday will come every 100 days, not every 365, and that the sky itself is running on a different clock. What if a year lasted only 100 days? Close your eyes and picture the calendar collapsing. Seasons that used to stretch for months now passing in weeks. Birthdays and anniversaries arriving 3 times faster. But this is more than a calendar trick. It means Earth would be racing much closer to the Sun, and that changes everything. Let me explain what that would actually look like, step by step. First, a quick fact. 1 year today is about 365.25 days, and planets follow Kepler's rule. Shorter orbital periods mean much smaller orbits. If Earth's orbital period dropped to 100 days, simple celestial mechanics says our average distance from the Sun would shrink to roughly 4/10 of today's distance, closer than Venus, almost in Mercury's neighborhood. That sounds small on paper, but sunlight grows brutal the closer you get, because intensity scales like 1 over distance squared. Right now, the solar energy at the top of our atmosphere is roughly 1,360 watts per square meter. Move inward a few tenths of an O, and that number multiplies fast. So what's the immediate weather? Short answer, much hotter and much faster swings. Seasons would still exist if Earth kept its axial tilt, but they'd be compressed, each season roughly a quarter of a 100-day year, so about 25 days long. Plants that rely on long-growing seasons would be shocked. Photosynthesis schedules, flowering, migration, and breeding cycles tuned to months would now need to happen in weeks. Farmers would face a nightmare of compressed growing windows. Crops that take months to mature might never make it, or would need genetically extreme acceleration. Wildlife with annual cycles, birds, insects, whales, would either adapt fast, shift to new life history strategies, or crash. Human society would feel it too. Holidays would come faster, but so would resource cycles, water, food, and energy demands would spike in new rhythms. Now the really scary part. Because we'd be nearer the Sun, the equilibrium temperature of Earth would climb dramatically. Not a few degrees, but scores of degrees. At the new orbit, the raw sunlight would be several times stronger than today, enough to raise the planet's basic radiative temperature into the hundreds of Kelvin. That means vast regions that are now temperate would become arid ovens. Ice would retreat fast. Weather patterns would rearrange into more extreme, faster systems. Coastal cities would still exist, but the climate regimes that sustain agriculture and water cycles would shift poleward and perhaps even fail locally. Oceans would absorb more heat. Evaporation would increase, driving stronger storms and shifting precipitation patterns into chaotic, sometimes violent regimes. Over years, increased solar wind and radiation at the closer orbit would also stress the upper atmosphere, potentially accelerating atmospheric loss processes and changing ozone chemistry. There are longer-term orbital mechanics effects too. A smaller orbit means higher orbital speed, altered tidal interactions, and a different interplay with the Moon. The Moon's stabilizing role over climate could be affected. Human infrastructure, power grids, cooling, agriculture, coastal defenses would be under continuous strain as the environment cycles faster and hotter. Economies would need to become radically more flexible. Food production accelerated, storage technologies, new energy priorities, mass migrations perhaps toward remnant temperate zones. Culturally, our sense of time would change. A year compressed to 100 days would reshape law, education, fiscal planning, and the pace of life. But here's the twist. Not everything becomes instantly uninhabitable. Cities and technologies adapted to heat and radiation could survive in pockets, and life is tenacious. Microbes, hardy plants, and engineered crops might persist. Yet the overall picture is brutal. Many ecosystems would collapse. Sea levels would rise as ice melts, and human societies would be forced into rapid, difficult transitions. If you want a rough anchor for how extreme this is, Mercury orbits in 88 days and already bakes in intense sunlight. Putting Earth into a similar zone multiplies the solar input many times over. So the takeaway is twofold. A 100-day year compresses time, seasons, life cycles, economies, and it also moves Earth into a much harsher sunlight environment that would fundamentally remap habitability. It's a vivid thought experiment, but it illuminates how finely tuned life on Earth is to the length of our year and our distance from the sun. Change that clock and you change everything. The biology, the weather, the calendars we take for granted. Still, the human story is resilient. With technology, planning, and hard adaptation, people might carve out survivable spaces, but at enormous cost and loss. If this kind of what-if fascinates you, hit like so I know to make more hard science thought experiments and tell me which cosmic change you want next. Don't forget to subscribe, and I'll see you in the next much shorter year.